Welcome to Accelerated Engineering. My name is John. This is the video encyclopedia entry for the BINOM.DIST function, or the binomial distribution function. This is the modern version of this function. There is a compatibility version, BINOM.DIST, which does exactly the same thing and seems to have the same limitations, but this is the newer one, so it's probably the one that you should use. It's definitely the one that I am going to use. So what the binomial distribution function does is it answers the question, well, here's a specific example that I've set up for this one. What I've asked Excel in all of these cells is, if I flip a coin 20 times, what is the probability, or what are the odds that it comes up heads exactly x times? So here are the values of x. This is my value for the number of trials, and I've tucked my probability up here. 0.5, I've assumed, for example, a fair coin. And what we can see inside of this function, you know what, that's too complicated. Let's just go equals binom.dist. There we go. See, the first argument it takes is the number s. And the number s is going to be account for the number of successes. It's asking, how many times do you want to see? It's the, what are the odds that it comes up heads exactly x times? I should actually reword that. What are the odds that it comes up exactly s times? Do it that way instead. So I'm going to say, what are the odds in this case that it comes up exactly 10 times? 10 times. The number of trials is how many times have you performed this? So if we're going to coin flip, I'm going to say that I flipped a coin 20 times. The probability of getting heads or tails is 50-50, 0.5. And cumulative, I'm going to put as false. And this tells me that I have about a 17.5% chance of flipping a coin 20 times and getting exactly 10 heads. So let's look at these arguments in a little more detail and what they can be. The number s has to be a positive integer. If I do something crazy with it and give it a weird value, you'll notice that it stays the exact same output value. This input integer gets truncated. If I put in a negative value, I get a number error. The other thing is that, obviously, if my target number of successes is greater than my number of trials, it will also throw a number error. If I flip a coin 20 times, I can't get 21 heads. That's just absurd. So those are kind of the limits for the number s, or the number of successes. For trials, this can be any whole number integer. Again, throwing a non-integer number will result in a truncation. So that's that. Negative numbers throws a number error. And then the probability of s, or the probability of a success, must be a number between 0 and 1. That's how probability works. And that makes sense. If there's a 0 probability of getting a success, then you have no chance of ever getting 10 heads. And that's not a very fair coin, just for example. And if there's a probability of 1, meaning that it's every time, it still evaluates to 0, which I think is a little bit silly. It should tell you that you have to get, like, you will get 10 successes. Actually, no, sorry, that's not true. If I'm targeting 10 successes and my probability is 1, it's every time. It means that every time I do 20 flips, I get 20 heads. My probability of getting 10 is also 0. That makes sense. If I input a number larger than 1, I'll get a number error, because you can't have a probability of something happening that's greater than absolutely certain that that will happen. And then the last parameter, this cumulative function, is a slightly different question. And I'll just change one of these columns to show the cumulative instead. Change it to true. Aren't you showing? There we go. There we go. The orange line shows the cumulative distribution. And what that means is, instead of asking the question, what are the odds that I get my success exactly this many times, it's what are the odds that I get my success this many times or less. So for example, at the value 10, this is about 0.6. And what that means is that there is a 60% chance, if I take a fair coin and flip it 20 times, there is about a 60% chance that I will get 10 heads or less. So 10 or 9 or 8 or 7, etc. That's what that means. And that's what the cumulative part is for. It's just whether or not we're accumulating that value. Yeah, so that's for the specific case. This is the general. That's poorly worded. I'll figure out a better way to word that another time. Any which way. Let's take another example to see how this skews. Let's say, for example, a 4-sided dice, and I want to roll a 4. That's my success. It has a 1 in 4 chance, or 25%, or 0.25 probability of happening. And if I punch that number in, we can see everything shifts around. If I do the same here, 5. My odds of getting 10 successes is less than 1%, just less than 1% of getting exactly 10 guesses, 10 flips correct. Now that looks like it didn't quite behave the way I wanted it to. Did I get a weird number of... Oh yes, of course that makes sense. If I roll a 4-sided die 10 times, I have about a 1% chance, like 0.99% chance of rolling it a 4 exactly 10 times. And that's how the BINOM.DIST function works, and that's what it does. Yep, that's the gist of it. So some related functions to this are going to be the binomial distribution range, which we'll get to in a minute, binomial distribution inverse, which does this but backwards, and it's pretty neat. Anyway, this concludes the video encyclopedia entry for the BINOM.DIST function. Please take a moment to like and comment if you have something to comment about, and subscribe if you want to see more content like this. Thanks for watching. Happy excelling!